Kids are on KSPS.
Welcome to Rough Science from the island of Carriacou off the coast of Grenada. Based at a derelict lime factory, 5 scientists are getting back to basics to try and solve a series of challenges. Now, this is about science, not survival, so ingenuity and cooperation will be the keys to their success. With nothing more than their wits, some simple tools and the natural resources of the island, our team of scientists will have just 3 days to solve a series of mind-bending challenges. Will our intrepid scientists succeed? Find out next on Rough Science. Right, guys, we've all had a good look at the island over the last few weeks, but we haven't had a good look at the sea. So don't you think it would be brilliant if we could make some kind of torch or light source that could work underwater, Mike and Kathy? And you'll need something to power it. We've got the car battery, but it has seen a lot of action over the last few weeks, so I think it's going to need its charge topping up and probably its distilled water topping up. So that's where you guys come in. If you can make electricity to top up that charge, and if you can turn seawater into pure distilled water, but here's the challenge, without using any fires. We want a renewable energy source. Okay? Got 3 days, as usual. Let's get going.
Electric light.
Underwater. I think this is really hard.
Well, maybe one on the surface wouldn't be too difficult.
No, I think that'd be okay. We could make a torch, just a little bulb, couldn't we?
Yeah.
Yeah?
You could.
Oh. Well, just a little,
just a filament.
A filament, put a voltage across it. I can just use a bottle on top.
Or what ideas have you got for filaments?
Well, I could try out all the different wires they've got.
Yeah.
Have we got any other ideas, then?
Well, I got an idea. I'm going to make phosphorus. Well,
You're
I'm
not.
going to try and make phosphorus.
You're not? You're mad.
It glows in the dark.
That'd be amazing.
Yeah.
How hard is that?
Really difficult.
What are you going to make it out of?
Bones.
Bones.
I've seen some bones around the fields here, so I'm going to go and collect bones and try and make some phosphorus. There's another light source.
Fantastic.
Yeah, but we must work together.
Yeah, keep on talking. Hey, and what about the fireflies? I think we should catch some fireflies.
Train some fireflies?
Yeah, put them in a bottle, hold it underwater.
They only do that to attract sexual partners. There's no reason to just dance around provocatively like a fire.
Well,
We'd really rather you didn't, actually, Mike.
Jonathan, as always, has come up with the Rolls-Royce of solutions to top up the distilled water in our nearly dead battery, using a renewable energy source.
Okay.
He's set his heart on a distilling machine powered by the sun, using a very special shape and a lot of mirrors.
Need to get some broken bits of glass to make the shape of a parabola.
Ellen's been drafted in to help. Mike Leahy is looking pretty confident about the challenge to recharge the battery.
Well, I mean, we've got to make electricity. And it'd be nice to use something here, but I've been thinking about waves, and I can't see how we're going to do that technically. There isn't a breath of wind, there are no streams, so we can't use water power. And, you know, it's all very well using solar power to make things hot. But even with modern technology, it's difficult to harness solar energy, and I certainly can't. So I think it's going to be manpower, just a simple generator powered by muscle power. And Ellen is helping us on this challenge, isn't she? And she's quite muscly.
But for now, Ellen's using her muscles to collect shells, something to do with making grouting. All will be revealed later, apparently. Mike's hunting for old cow bones. Kathy's gathering coils and wires from the toolkit.
And Jonathan, well, he's got a touch of the Leonardo da Vinci's.
Jonathan, you're not supposed to be making flying machines.
It's not a flying machine. Not yet, anyway.
What's it going to do?
This is our parabolic surface, which we're going to cover in mirrors, which is going to collect the sun.
Parabolic surface? That's
Yeah.
not the sort of wood you've used, presumably.
No, the actual shape is a thing called a parabola.
Right.
Which is a mathematical shape. And it has an amazing property that when light hits the surface, just imagine this is covered in mirrors.
Yeah.
It's always reflected to the same point. So if a bit of the light hits here, it gets reflected to that point. A bit of the light hits here, gets reflected to that point, and so on.
And the same this side as
Yeah.
well.
So
So it's perfect, is it? A perfect arc, effectively?
Yeah, it's a special shape called a parabola, which has this special property. And the amazing thing about it is if we have something here we want to heat, we're effectively heating it with all the light captured here and here and here. So we're putting all the sunlight that's captured over this surface onto one spot.
So the salt water will go to your magic point?
Yeah, there's this magic point, the focus point, as it's called, is where we'll put the salt water in a container. Put maybe a tin box. I'm not sure, we haven't decided on that yet. And then all the sunlight collected by this will be focused to and heated, you see. And that's your boiler, hopefully.
Once the evaporated steam cools back down to pure water, it'll be collected, free from salt and impurities. In theory. To keep the process going all day, Jonathan's made a turning base so the parabola can move and track the sun across the sky. Ellen's been cooking.
Okay, this is 1 pot of baked conch shells. We've turned calcium carbonate into lime, which is calcium oxide.
She assures me that calcium oxide mixed with water and sand will make grouting mortar. Great for sticking mirrors to homemade parabolas.
So is this your electricity-making device?
Yeah, it's just a really simple generator. And it works by taking these wires, which are conductors. They conduct electrical current, and it passes them through a magnetic field. And then we can harvest the electricity, if you like, off this metal ring here.
So it's literally as simple as those wires going through a magnetic field make electricity?
Yeah, sure.
Really?
Yeah.
That's quite clever, isn't it? And why do batteries actually run down?
Well, put simply, you're storing electrical energy as chemical energy.
Right.
Using a reversible chemical reaction. So, as the battery supplies current, the reaction goes one way. And then, when you charge it up, you force the reaction in the opposite direction, and so you're storing current. And that's why some batteries are rechargeable and some aren't. Some are dependent on reactions that can be reversed, and others are dependent on reactions that will only work in one direction.
So what's the next stage with this?
Well, I want to mount this on something that will turn it fast.
Yeah.
And I've got some ideas.
OK. Well, I'll let you get on, and if you need a bit of willing turning later, give us a shout.
You wait till you see what you need to turn.
I shouldn't have said that.
No, you shouldn't.
Mike's not the only happy rough scientist. Ellen and Jonathan seem quietly content too, pinning mirror fragments to their parabola. Although I wouldn't be quite so confident. It's just started to rain, and if there's one thing a parabola powered by the sun doesn't need, it's rain. Even if Mike B and Kathy seem to be enjoying the downpour.
Oh, it's so refreshing. It's by that kiln all the time. It's lovely out in the rain. Oh, put some spectacles on.
OK. So, is there any reason that you're bashing the living daylights out of this poor, unfortunate creature's remains?
This is a Delia Smith recipe.
Is
You
it?
take half a cow. We're going to grind the bones up to fine ash, but so the first step of that is just to bash them into small pieces, then we put them in the kiln.
Sorry, am I being really dense here? You're going to grind bones up into fine ash, put them in the kiln. What has this possibly got to do with a torch?
Ah, well, the bones contain calcium phosphate.
Right.
I mean, if I treat that with charcoal and a bit of sulfuric acid, I think I might be able to make phosphorus, which glows in the dark.
Can you use any old bones?
Well, I think sheep bones are better than cow bones. We're going to have to make do with cow bones because
Yeah.
no sheep around.
But cowbone crushing can't go on forever. Even if the rain seems to be able to. Kathy dries off and is finally working on her light bulbs.
Wow. So you're going for the electrical approach rather than burning bones?
Oh, yeah, I'm going to make a bulb.
You're, what, like a regular light bulb? Something
Yeah.
that we would all recognise?
Well, it won't be recognisable, but I hope it will be a bulb, yeah.
OK, talk me through it. What are you going to do?
Well, I've got here just a little bit of thin wire, one that I think might be a nice filament.
Right. So that's exactly like the curly thing you have in a light bulb.
Absolutely.
Yeah.
That's it. And I want to hook it up to the battery here. But I'm afraid that, because I don't know what these wires are, I'm afraid that if I just put this huge voltage across here, it'll just burn out really quickly.
Okay.
But I've put this in here it's a resistor.
Right.
Okay, and that's just to be able to protect this thing, so I can gradually let more current go through this thing.
But the battery is running worryingly low on charge. Where's that generator?
I reckon that's got it.
Brilliant.
That's going to give us plenty of power.
Because that must be, what, 10 to 1 or more gearing?
At least it's got so much weight.
Well, that looks pretty impressive. Mike B's phosphorus, on the other hand, looks like cement.
So taking the bones from the kiln, cooled them down and ground them up, put them in here with some sulfuric acid from the car battery. And that produces a compound from which we'll be able to extract the phosphorus. And I know this reaction's worked because it's formed this milky liquid. And the precipitate here is calcium sulfate or gypsum. So step one's a success. I think I'll just leave this to steep overnight, just to make sure reaction's complete.
End of day 1, and it's hard to believe that this porridge may soon give us light. But Mike B seems utterly determined to make it glow in the dark. Day 2. Kathy and Mike need to go on an underwater recce to find the safest and easiest spot to use their underwater torch. Back at the lime factory, it's time for Jonathan's amazing parabola to get to work and finally feel the heat of the sun.
Whoa!
Whoa, blimey. Feel the sun. Yeah, then where's the... Oh, yeah. Can look on this side, how bright it is.
Oh, wait. If you put it right there.
Yeah, the
Right
sun's
there.
not directly overhead yet.
Yeah.
Wow, you can feel the heat, blimey. Can you feel the
Oh,
heat?
my gosh.
So that's quite a good place to put it. You can feel the heat.
Because
can't
it's
you?
not hot here at all.
That's about half a metre, which is about right. Isn't it? It's about right.
Ooh, it's hot here,
It's really hot.
and then it's not hot here.
Yeah, you can see where the focus is, can't you?
Yeah, it's right here. Ooh.
So long as the sun's out, the parabola should be able to track its movement. Mike is not so happy, though. His generator won't produce 12 volts.
After all the modifications, I'm ashamed to say it's got progressively worse. But we'll get there. It'll be all right.
So I'll get rid of that.
Back from their swim, Kathy and Mike are testing potential filaments.
What kind of properties are you looking for?
Well, I want to get really high resistance.
Yeah.
Okay, so that
It glows, it heats up.
I want it to heat up and glow. But what I don't want is for the whole thing just to burn out, because it might do that. That's the biggest risk,
Like
I
a
think.
fuse. The principle of a fuse, isn't
Yeah,
it?
absolutely. That's right. In a fuse, you want it to blow out, but I don't want this to. Okay, it's not doing much yet. I'll probably have to go straight onto the wire.
There we are,
Oh.
glowed.
Oh,
well,
it glowed and melted.
just like a fuse.
Yes, okay, so that one's no good.
Ellen's mixed her mortar, and it's time to permanently grout the mirrors onto the parabola. It should stop them falling off when Jonathan moves it to track the sun.
So what do you think of the setup?
It's, well, we got something.
Oh, really?
We have, yeah. Yeah. I mean, it's not... I thought it was going to be a bit hotter, I must admit. I thought this... But it's basically too hot to hold now. But it's not
Ooh,
boiling.
yeah,
It's nowhere
yeah,
near
yeah.
boiling. But it doesn't have to be boiling to give out a little bit of vapour. And we're definitely getting stuff off it. It's not a lot.
But there's a teaspoon there.
Yeah.
That's fantastic.
It's brilliant.
Okay, Kate, I'm going to give you a lesson in bulb making.
Go on, then.
Okay, now, this little filament here, you've already seen that glowing away.
And is this... You've done various tests now, haven't you? Is this your perfect
This
filament
is
now?
the best filament I've got.
Okay.
And what I'm doing is running this one side by side with one that I'm going to put inside my bulb.
Okay.
Now, the problem with this, guy, is that it's going to start to burn. That glow isn't going to last forever. It burns away because of the oxygen in the air.
Yeah.
So what I want to do is get this into an environment where there's no oxygen. Okay?
Right.
So the way I'm going to do that is burn the oxygen away.
Fantastic. Okay.
Okay,
So do you want that screwed on top of there?
Yeah. Get that onto there. Screw it down. If it doesn't go out, that'll tell us that I haven't managed to get rid of the oxygen very well. Yep,
It's
so
gone
the
out.
oxygen should go.
Okay.
Okay, I will connect this. Are you ready?
Yep. Oh, wow, look at that. Oh. The opposite happens, Kathy.
Well, I wasn't very careful about these being both exactly the same length. I just did it by the number of turns.
Are you making excuses by any chance?
I may be. And maybe this one got a bit wet, and maybe my theory isn't right. But I think it's probably because the lengths weren't absolutely equal.
Well, it glowed beautifully for a while.
Poor Jonathan's chances of success have been blighted by the weather.
Yeah, it doesn't look very hopeful for getting lots of sunshine today, I must admit.
And that's the problem with solar-powered energy. You're sort of relying on the sun to turn up.
Hey, Kate, come over here, have a look.
What's going on?
I'm trying it again.
Okay.
In here I've got different filaments. There's one that's 12, then 11, and then 10 centimetres long.
Okay.
I've got one outside that's 10 centimetres long. Okay, and I just want to compare them. I think, if the theory works, these guys should stay lit and that guy should just fizzle away. Oh,
He's fizzled.
he's fizzled and he's
None
still
of
going
these are
strong. And you see this one, it's brighter than the others.
And that's your 10
That's the
centimetre
10
one.
centimetre one. That's 11 and that's 12. And it's bright, darker, and then least dark. So this is the best one, and it isn't fizzling. The oxygen depletion has worked.
And your physics isn't going backwards anymore.
Congratulations. Kathy's chuffed. Mike B's labouring on with his primordial gloop.
So what I've got to do is get this liquid off the top. I don't want the solid at the bottom. I want the liquid because that contains the phosphoric acid that I'm going to heat with charcoal to make phosphorus. And this has got to work. This really has got to work. I mean, I've failed at so much in this series. I'd just like one thing to work, and this would be really magnificent. Chemistry in action. Magical transformations from bones to glowing phosphorus.
Mike B may want a magical transformation, but at this rate, Mike Leahy is going to have to rely on one.
It's going to move.
If it moves, we know it works.
Yeah, yeah.
OK, Mike, moment of truth.
OK.
3, 2, 1, go. It didn't move.
It's a problem with the voltmeter. Definitely. Oh, no. Oh, no. You don't want to look in there now. You really don't want to look in that thing now.
The copper wire is all stuck around the magnets. This isn't good.
It's not good, is it?
Kathy's blissfully unaware of the serious lack of electricity and is happily putting all her bits and pieces together to make her first underwater light bulb. Ellen's made her some extra strong sealant from the sap of the strangely named tourist tree. Mike B's collected a lot of clear liquid that he hopes is phosphoric acid. Which, yes, you guessed it, needs more cooking.
Right, just got to dry the water off now. Concentrate it.
Dusk approaches. There's just enough power in the old car battery for Kathy to try her first prototypes.
Just to
With you,
show.
Kathy.
Just to show you that it works, though.
Oh, yeah.
You can see the filaments glowing.
OK.
Mike B sits long into the night guarding his magical potion as it gently distills in the kiln. He really is very keen for this to work. Next morning, time to see if the obsession has paid off.
There's something in there.
It's out now.
Now that looks promising. That looks very promising. You see that white waxy solid in there? That could be phosphorus. But because it's sealed, there's no air in there, there's no oxygen in there, so it won't be glowing. It's only when the phosphorus meets the oxygen that it will glow.
How do we find out if it is phosphorus then, Mike? Are we going to open the tube?
Yeah.
If there is phosphorus, Mike, and it is glowing, how long will the glow last?
A lot, you know, days.
Days?
Yeah.
Wow. So this is the moment, Mike?
Yeah, stand well back. Let's see what happens. There we go. Oh, it don't glow.
No?
No.
No glow?
No glow.
Oh, Mikey!
No, don't despair, don't despair. We got your light bulb.
Oh, but it's been such hard work. And I wanted to see phosphorus.
Yeah, but science is like that, isn't it? Hard work and negative results. But,
Sometimes.
you know, give me a year, I'd have done it.
Poor Mike B. But has Mike Leahy done it? Has he made a working generator?
OK, Mike, I've had enough of you messing around. It's
You're
going to
not the
work
only
this
one.
time.
It's going to work. I hope it's going to work.
Third
I
time
really
lucky.
hope it's going to work.
Third time lucky, OK.
OK.
Are you ready?
I'm as ready as I'll ever be.
I'm watching the meter.
OK.
Go.
Oh, it's my
Come on, Mike! Come on, Mike! At last! We have electricity.
We'll be well worn out by the time the battery's charged, though.
Well done. Thank goodness for that.
Kathy's bulb will have electricity.
So what improvements have you made?
Well, I've just whopped this silver metal thing at the back to reflect light. It's a bit like Jonathan's parabola. That's the idea, to reflect light forward so that light being scattered in this direction gets kicked forward and we might be able to see that way better. That's the idea. So let's have a go. See what you think.
Oh, yeah. I think it's amazing that you've made a light bulb out of bits and bobs. It's astonishing.
Me too.
And it's amazing that Mike's finally charging up the battery. But will the parabola prove amazing too, even in the rain?
How are we getting on with this water, guys?
Well, as you can see, we had a bit of rain today.
We did have a bit of rain today.
But we do have water.
Yeah, we got a bit.
This is what we've distilled so far.
Oh, fantastic. So this is not going to be salty. Is this the idea?
That's correct.
Right.
Can
The
I taste
salt's
it?
still in the kettle.
Just
Only
to
water
check.
came out.
This is distilled water.
I'm not going to take too much. It's not salty. It worked. Brilliant. Do you think this is going to be enough, though, for our battery?
No, I don't think it is. But because it's been raining, I did actually put loads of jam jars up. I have actually got quite a lot of rainwater here.
Jonathan. Well, I do admire you, because you could have put it in there and said you'd distilled a lot, so, OK. Hi. Hello. Oh, is it all right to stop it? It's not going to go all pear-shaped.
Yeah, it's going to take ages to charge anyway, but luckily the weather's warm, so that'll help the reaction going.
Good. I've got some distilled water for you and a bit of rainwater if you haven't got
OK.
enough. What do I do? Just top it up?
Yeah, just pour it in there. If you see those plates, it's got to cover it up.
OK.
It's just to replace the water that's lost by evaporation during the reaction. You can put a bit more in, actually.
How's that?
Perfect. Spot.
Well, things have finally come together. Time for a group boating jaunt to test the underwater light bulb underwater out on the reef.
Well, it's the culmination of all the challenges, so hopefully the battery now is going to work because of your muscle power.
Definitely going to work.
OK, I trust you, And it's beautifully topped up with your distilled water made by the parabola. So, Kathy, Mike, big moment. Is it going to work under the sea?
Let's try it up here first.
All right, then, fair enough.
Make the connection.
Yeah, there's
Yep,
a definite
filament's
glow.
glowing.
Definite glow, OK.
Okay,
Big
you get the rock
moment.
over.
Do you want me to hold this?
Yeah.
I've got the way to the rock.
Okay,
Yeah.
take it down.
So it's not lit at the moment, is it?
No.
You've got the rope?
Yeah, I got the rope.
How's it doing?
It's not leaking.
It's not bubbling.
No air bubbles coming
No
out.
air bubbles. That's a good sign. Brilliant.
Okay, is it on the bottom?
Yep. And it's still not
This is the
leaking.
moment.
Can I come peep?
Not yet.
Can I peep?
How about that?
That is amazing! Congratulations! Can you see? absolutely fantastic.
You guys are incredible.
How many metres down do you think that is?
it's about 2 metres down.
About 2 metres, and we can see it
We can
from
see
here.
it from here, you're right.
That is
Still
brilliant!
airtight, too.
No air bubbles.
That's fantastic, and that's all from Rough Science for this week. We'll see you next time, but from 5 delirious scientists and lots of very confused fish. Bye.
Rough Science continues at PBS Online. Point your browser to pbs.org. To order a home video copy of this show on VHS or the entire 10-part series with additional features on DVD, please call 1-800-543-3764.